Hey everybody, we're going to talk about a different way that we can go through and solve systems of equations. I'm Mr. Hayes. This is Hayes' World of Math. If you like what you see, like, subscribe, all that other good stuff that Mr. Beast would tell you to do. We're going to talk through, we're still going to Spain with Mrs. Nelson's group, but we're going to talk about it in a slightly different way. So, having led groups overseas before, getting groups to know each other is important. So Mrs. Nelson does that. By having a pizza party. She remembers that she ordered 5 pizzas, 3 loaves of garlic bread. It cost her $52, but has no recollection of how much the pizza is when somebody asks, because apparently they liked it a lot. So she does remember that the garlic bread was $4 each. So take a second, play around with that, and see if you can come up with the answer. I don't need equations. I don't need setups. I just need you to talk through what happened. So you're going to go ahead and right here, come up with the answer, and then down here, explain what you had. Hit pause while you wait, and we'll come back and talk about it. Okay, so welcome back. You should hopefully have an answer of $8. And when I ask students to explain it, they do it a variety of different ways. But what usually comes up happening is this. They know that they have pizza. They know they have garlic bread. So those two things added together equal $52. So then they start messing around with things. Some of them do it by guess and check. Some people usually come up and say, well, we've got $12 on garlic bread. How did you guys spend $12 on garlic bread? Well, $4 times 3 loaves. Great. And so that allows us to come back here and figure out how much price was here, how much pizza was there. So we spent $40 on pizza. And so from there, we just continue to go backwards and say, okay, well, we had 5 pizzas for $40, and so therefore we spent $8 on it. All right? How does this have to do with systems of equations? We will get there, don't worry. Same thing down here. Now, after the pizza party, you and your best friend go to a resale shop to see if there's any good clothes. Your BFF ends up buying 6 shirts and 2 pairs of pants for $40. The cashier says, wow, that's an amazing deal. These shirts, you can get 2 shirts for the price of a pair of pants. Now, knowing that they spent $40 total, how much did your friend pay for? I think it says pants, but how much are the shirts and the pants? So again, hit pause, play around with it. I don't care how you come up with it. Just see what you get. All right, so a whole bunch of different ways of doing this again. So you've got this $40. And again, how you set this up, whole variety of different ways. You could set it up where you say, okay, this is the one that I usually start seeing people have equations. They're like, okay, that's 6 shirts and 2 pairs of pants. Oops. And then they start messing with numbers. Lots of guessing and checking, and that's okay. Okay, that's how you can get a feel for things. I had one student do this, which I thought was kind of a neat way of doing it. They said, well, wait a second. Okay. So we have a pair of pants. We have a pair of pants. And they said, what was the phrase right here? 2 shirts cost the same of each pair of pants. And they said, okay, so if I take the other 6, so they said, okay, 6 shirts divided by, or actually, no, they just did this. Yeah, 6 shirts divided by 2. So they went 6 divided by 2, that equals 2 shirts, or that gives me 3 sets of pants. So they had 2 shirts, 2 shirts, 2 shirts. Sorry for the scribbling there. But then they went through and they said, okay, all of this costs $40. So what happens? I've got 5 equal things that equal $40. So again, we come up with 8 for your pants. Because again, they've got 1, 2, 3, 4, 5 things here. 5 parts equal 40. And I thought that was really kind of ingenious. And they did something that was really neat that we haven't done yet. So let me show you that. Now remember, right here, and you can do this, I'll show you 2 different ways of doing it. They said, okay, this really is equal to, well, this is kind of what they did. This is really equal to 3 pants, right? Because 2 shirts, 1 pants. So then they did this. So they changed the shirts into pants, and all of a sudden, here we go. We're in business. Instead of talking about shirts and pants, we're just talking about pants. Somebody else did this, which I thought was kind of cool. So they had, again, same equation, same base information. Now notice I'm not using variables here. I don't, especially in the beginning, like using variables because it's very easy to lose what you're doing. Okay. And by keeping the shirts and the pants, it kind of keeps you grounded in the problem. But anyway, what they ended up doing, well, wait a second, each pair of pants was 2 shirts. So this, okay, that's equal to 4 shirts. So they went 4 shirts, 6 shirts, and that has to equal $40. So then they got 10 shirts. So each shirt equals $4. And then they doubled it to get the pants. Okay? But this idea of taking one value and trading it for something else, that's going to be the whole gist of what we're doing today. You'll see what I mean by this last problem. All right. So take a second, try this. You're going to go see flamenco dancing. Try to get that Spanish culture in you, and we'll see where things go. All right. So the whole thing kind of hinges on these 2 equations. Now remember we talked about what a system was. A system is where you have equal values in 2 or more equations, or the variables have the same value in 2 or more equations. So I had a student, and this is usually kind of where things go. Do something like this. And actually it's a lot like what we did with the pants and the shirts. They did this. And they said, all right, well, this is really equal to adult equals 3 students. So they said, okay, this is really like 6 student shirts. Or student tickets, I'm sorry, student shirts. What am I saying? So we end up getting 20 students. Is equal to 120. So then a student ticket is worth $6. And then from there you can figure out how much the adult tickets were, or the teacher tickets, right? Because an adult equals 3 students. The students, we're going to substitute that out, right? We're going to trade it. What's the student ticket price? Oh, the student ticket price is $6. And I found this year actually that using the word trade, I think almost worked better than substitute. So we'll see where that goes. But we need both parts of this. So we're going to write that down. So we traded this student one for 6. Notice we also here, we traded 3 students for every adult. Okay? So we're going to hit pause here. This is the experience of what we're doing. The video linked on this that should pop up next. Hopefully, if you're using the playlist, we'll explain some more of the theory about this, and we'll go through some more of the regular algebra versions of this. But hope you find it useful. We'll see you in a minute.